Hello, Internet. Welcome to our episode 9 of mentoring session on C++. In this particular session, we are going to talk about the file handling and the exception handling related topics. And let's start with our first review of the episode 8, whose video was premiered today itself. That is on May 27, 2 o'clock, we premiered it, and it's now available on my YouTube channel. You can watch it if you have missed the premieres of this particular video. So, what we discussed in that particular video, we discussed about the operator overloading and static members and the class templates. In operator overloading, we actually spoke about that how user defined classes and the relevant uh, objects can be manipulated corresponding to a particular set of addition, subtraction, or multiplication operator. You can simply use an operator keyword and define it as a simple function. You have to pass a user defined parameter to this particular system. Apart from this, we discussed about the static members and static member variables and static member functions, where we have actually looked at that how the memory allocation has been done corresponding to both of these type of members, how a function static function can access the static variables, and how a single unit of memory location can be shared across the objects. Similarly, the class templates, when we were discussing about it, we compared it with the function templates, and we defined that how we can do a generic programming by using these class templates into our particular system. So today's agenda is the file handling and exception handling. So I'll try to cover this particular set of topic within next 45 minutes, and then we can have queries if there are any among you. So starting with the file handling. So if we look at this particular image, it contains a hierarchy of the streams which are available in C++. So they are basically the classes. So the top level hierarchy is basically the iOS input output system stream, and this, if you talk about, is being derived by a lot of different set of classes: the iStream, stream buffer, OS stream. This particular iStream and OStream are actually being further derived in the IO stream. So that means this is what we have been using for C out and C in till now. Apart from this, the other files which are being also derived from these set of iStream or OStream is the IF stream, F stream, OF stream file buffers. The file buff is actually being derived from the stream buff. So this is more or less a buffer for the file based handling. This is for the C out or C in console based buffer handling. So if I talk about the IF stream, it is also being derived from the F stream base, right? So IO stream is being utilized or derived from the uh, is being derived further with F stream base, and then this F stream is being further derived in IF stream, uh, F stream, and OF stream header files. Now, if we look at this very carefully, there from here and here, there are two particular uh, base classes are there for this particular OF streams, and same is for the IF stream. So that means the multiple inheritance has been there corresponding to all these files, whereas this is a single inheritance which has been done for this particular part. So we can clearly see that this particular bottom section is for F stream files, and this is for the I stream files. So that means this is for the console based input output. And this is for the file based input output, right? So these are some set of files which you should remember. If the question is asked in any of the placement session, you can go through this, and you can share the details with them. Now, classes which are there for the file handling, I have already mentioned in the previous slide as well. So OF stream, IF stream, and F stream, these are the classes. And if we are making it very specific, so OF stream is for the output purpose or writing it onto the file. IF stream is for the input purpose, writing from the file, right? Reading from the file. And F stream is doing the both set of operation. So if we try to understand that how exactly this whole thing works, so we know that files are basically containing the collection of similar type of data, right? So that means it is supposed to be stored somewhere. So where it is stored inside a disk, right? And where it is being utilized, it is utilized inside a particular program. So whenever we are trying to read the data from a particular file, so that means we are going to take the use of if stream if I'm explicitly doing the operation of reading it from the file, right? So that means whenever I'm going to read, it cannot be read directly into the program. It is supposed to be fed into a buffer first, which is a input stream buffer, right? And that particular data comes to this particular program. So you should be very careful why this file buffer is there. This is supposed to have some kind of handling. So it's more or less a stream which is being maintained through the buffer. Now once the program has done all the processing on that particular data, it is supposed to write it back to the disk, right? So even in that particular case, it is supposed to have an output stream, right? And that is the buffer, and from this buffer we go and send it towards the disk and actually write the data. And here what we are going to do is the read the data. Okay, so this is what exactly happens. So for the writing, we are supposed to use OF stream, right? So this is the class what we have, and if we wanted to perform both the operations in the same set of object, then F stream is the object which is going to be created correspondingly to that particular section. So this particular hierarchy, this actually allows you to have an overall understanding that yes, there is a IO stream file which is a top level object, top level class, top level base class, and then it has been derived into further different kind of a set of classes which are responsible for either console or for either file. And for file specifically, if I am only doing the output or write to the file which is stored on, which is supposed to be stored on the disk, then OF stream is to be used. If I'm going to read it from the file which is already there on the disk, then I'm going to use if stream. If I'm doing both the operation, then F stream is the one object that is supposed to be utilized. Now there are certain flags, right? So because we wanted to open this particular file, there are certain flags which are supposed to be utilized. So let me take you to the code part first. So I have this particular file operation. It's the simplest file operation that we can do. So I'm using this example from c++.com again. So if I'm going to run this particular program, you can simply see what exactly has been included in this. So the pre-processing section contains the IO stream, F stream. IO stream is basically for C++ based console based things, and F stream is very specifically for inclusion of all those requirements for file handling. So when you talk about this particular section within the main method, you are using a OF stream for which the file object is being created named as my file, and then we are using an open function, and we are specifying a particular file which is available in this particular disk. If it is not available, it will be created for this, because OF stream is basically for writing on the disk, right? And then look at this particular operator very carefully. This is an operator, extraction operator. So that means we are trying to put the data, which is a string data, into the file, right? And this file, if I am writing this as like this is written from a live webinar, my 26:04 p.m. So if I wanted to write this particular thing inside the particular file, I need to do that. And once the work is done, the writing is done, the file is supposed to be closed, and things should be put to rest. So once I try to run this particular program, you can simply see that it is going to show you that okay, process returned, and the execution time that was taken to work it around is somewhere around 3 seconds time. Now here has not been any printing which was done to confirm the work. So what I'm going to do is I'm just going to take you to that particular place where I have actually saved this particular file, because I'm writing this program into a desktop C++ folder. And if I show you a C++txt file and open this particular file for you, you can simply see that this is written from a live webinar May 26 4 p.m. So this is how you can actually do an output on a particular file which is being available on a particular path, right? So you can give a full path over here, and you can write at a specific location as well. So this is the simplest form that is there for the particular file handling part. Now if we look at certain operations, because we have used a open function, there is a second parameter to this particular function. So if we say the second parameter, so that means we are talking about this particular part, the open function. The first parameter is always a file. The second parameter is for the flag, which actually allows you to have these kinds of flag for the purpose of particular operation which is to be done on the file. So if I'm using fstream, right, and for that particular fstream object, I'm going to have this second parameter. So maybe it could be like my file dot open, and within open I'm going to write c plus plus dot txt, and the second parameter will be ios n, right? So that means let's say this my file is basically from fstream my file, right? So this is what I have for that particular set. So this is the first instruction, this is the second instruction. So that means whenever I'm specifying this particular part, I'm specifying the input operation, right? Similarly, for output, we can specify iOS scope operator out. So if we understood the scope operator in our episode 5, then we are sure that why this particular thing is being used, and in fact the episode 8 as well, because we spoke about the static elements. So iOS is a top level base class, and in is a static variable or identifier for that particular class, and doing a particular set of operation correspondingly. So iOS iOS binary for opening the file in a binary mode. iOS 8, this is to set the initial position at the end of the file, because I wanted to write that particular file. So I should be going to the end of the file. If the flag is not set, the initial position is at the beginning. So if I'm trying to open a file for input operation, right, in that particular part, I'm going to utilize this particular combination, right? So or this combination or this combination, it depends upon what has been required for that particular part. Similarly, app, this is for the this will take you to the end of the file and start appending the content over there in the end of the file. And similarly, trunk, if the file is open for the output operation, it already exists, its previous content is deleted and replaced by the new one. So it's up to us how we wanted to utilize these particular flags in our output parameter. So that is what we have for these particular combinations. So in fact, the combination how we utilize them, they can be utilized like this. So of stream my file is an object dot open, the name of the file. So that is file name we are talking about, and then we are saying that I wanted to have an output to that particular file, and I wanted to append to that particular file. So if you remember, app remembers what it does. All our output operations are performed at the end of the file, appends the content to the current content of the file, right? And then iOS binary. So I'm trying to open this particular file into a binary mode. So this is how the combination can be done by using these set of or operator, right? There are following type of default flags which are being set for a specific type of stream. So if it is OF stream, so by default iOS out is being used. So if you remember, in this particular part, there is no parameter, second parameter is provided. So in this particular case, because this is OF stream, so that means it is going to by default use the iOS out, whereas for iStream, that means we wanted to read from the file, so iOS in, whereas fstream, depending upon what operation we are trying to do on that, it will be used. So that means the combination of both the flags will be utilized. So the file can directly open using the constructor call as well. So there is another way how we can do it. So if we look at this particular part, uh, let me take you to the another file. So this is the another sample that you can see. What exactly is happening over here is, we while creating the particular stream object, we are directly passing on the particular set of file name, right? So example.txt is being given. So if I wanted to have a C++, that file can also be open directly from here, and I need to not to give explicitly the second parameter. So if I'm trying to have a second parameter because I wanted to, let's say, append to that particular system, so what we can do is we can simply write iOS colon colon, because I wanted to append it to that particular file, so I can do this by default, right? So in case if you want to specify iOS out, that can also be done here. Now what exactly it is going to do in the next line, it is going to check that my file dot is underscore open. Now this is a function which is going to check whether the file is opened or not, right? This is very, very important, because if I'm utilizing, if I'm not utilizing this particular construct, that means using the constructor to open the file, and instead if I'm trying to do it through the through the open function, so let me change it again to that open function construct type. So my file dot open, and then I'm going to have that construct over here with the open, right? So this is what I'm trying to do. So if by any chance I forget to do this particular step, this is open function is going to tell me that my file is not being able to open. So once I run this particular program for you, you can simply see the output that it is going to show me is the unable to open file. So this particular method is actually going to give us a flexibility to check in first hand that does my particular file is opened or not. If it is not, then there is no means to go further for this particular case. Now if I do this particular check and uncomment this particular file and run this particular program again, you can simply see the particular write operation has been done. And if I take you to that particular file and open that particular file for you, you can simply see that the first line which we have written by using the previous program, that has been written over here, and this is the line, and this is the another line that has been written from the current program, right? So maybe if you wanted to be sure that am I writing it from here itself, so my 26 and my 27, I'm writing these two things over at this particular place, right? So if I go further, let me close this particular file to avoid any issues. So I'm going to run this particular file again, and it says that okay, some process has been done. Now let me go and open this particular file again for you. So c++.txt, so another two lines has been added to this particular file. Now this appending happens on all because of this particular set of flags. So if I remove this particular flag, and now if I try to write, so let me have a C out here, and I'm writing that okay, file writing is complete. Okay, so this can be done by using a new line operator, and then I just simply rerun this particular program for you, and you can see that file writing is completed. And this time, because we have not used any append flag here, so that means all the content which we have written previously, that will be overwritten, and you can see that particular point here, right? So this is what is the difference, why these flags are effective to us. So if you wanted to do the check again, so I'm going to do a iOS colon and app, which is used for the appending again. So I'm running this particular program for you, and let me rerun. So you can simply see the file writing is complete. And if I take you towards that particular folder again and show you the c++.txt, now you can simply see it has been appended. So this is very, very useful in terms of utilizing these flags wherever you are required to, based on what procedure you wanted to perform. And these flags are basically for the input or output side. And fstream, basically in fstream you have to specify this, otherwise everything is by default. So multiple flags can be used by using the or operator that we have specified. So the other operations which can be done by using this particular file object can be, so is open, we have already discussed that it will check that is the file is opened or not. And it will simply allows you to have to avoid the exception that is going to be displayed on the runtime. Similarly, the close is to close the already open file, because once you open the file, it will be under the exclusive lock, right? Specifically if you are writing it. So we have to close the file every time we open it, and it's very, very important. Apart from this, if we are not able to read or write the operation, the bad function can be utilized in that particular case. And fail is also an extension for this particular bad function, which can be used in terms of the format errors which may happen while writing onto the particular file, writing or reading onto the particular file. Then EOF is another function which can be used. It returns true if the file open open for the reading has reached the end of the file. So a lot of time this has been used if we are trying to read the file line by line, right? Or we also use a get line method, which also does the almost similar work by finding the next line while get line we are using, and then it will be done. And finally, if we use a clear function, it can be used to clear all the flags which were being set for that particular file. Similarly, we can actually go for seeking the position. So let's say I wanted to go to a particular position in a particular file, right? So at that, for this, the tell g and tell p, this g stands for get and p stands for put. Same is here, g stands for get and p stands for put. So tell g and tell p, they return a value of member type stream ops, which is a type representing the current get position or current put position. So if I'm into reading, then get position will be there. If I'm into writing, then the put position will be utilized. So this is what to do in terms of getting the current position. Whereas the seek g or seek p, so g is while the reading and p is while the writing. So this is going to take me to that particular position, right? So this position is going to specify which particular offset do I need to go, right? And similarly, there are basically two different prototypes for this. So one is directly going to that particular position, and the second is going to that particular offset and then choosing the direction from where, from beginning, from end, or from current. So let's say I am into this particular position of the file. If I wanted to start the seeking from this point, then I am going to specify iOS beg in a terms of direction, right? So I will be starting from this, and then I will be going towards that particular offset. Whereas CUR, that means the current location, this side or the other side, and the iOS end is starting from here and going towards the other offset. So this is how you can actually specify certain kind of operations over the particular part. So let's look into the code. And let's go for the position. So this is what is there. So let me get to the file c++.txt, and I'm going to open this particular file. This is the input file basically. So that means by default it is going to be in a input mode. So beginning is equals to my file.tellg. So that means whenever the stream is going to get open, by default it is going to be on the top. So beg, that means this particular instruction is going to tell me that where is the beginning, and then my file.seekg and iOS end, right? And end dot tell g, that means because the seek g is going to take me towards the end of this particular file, then it is going to give me the end position. And once I close the particular file, I can actually do the size calculation corresponding to end minus begin, right? So that's in terms of the bytes we are calculating. So if I run this particular program, you can simply see that for C++, what exactly is the number of bytes that has been utilized. So it is 108 bytes that were being utilized from end to end, starting from the file and going to the end of the file. So if I make it like the offset, I'm going to have 10 offsets from the end. So you can simply seek in that particular case that we are having the 118 bytes. So that means we are moving ahead of the end in that particular part, right? And similarly, if I am on the current CUR, right, in that particular case, we can simply seek that what is the bytes that are being going to be printed. So it is the 10 bytes that we have in terms of our particular program, because my tell g at the beginning of when I open the file, my current cursor is at the beginning, right? So in that particular case, the tell g is going to give me the first position of within the file, and then the seek is going towards the next 10 position from the current position, and then it is going because wherever the current position of my particular file, that will be recorded in end, and this is how you are actually going to get your current set of bytes on the basis of the subtraction of both of these end and beginning. So this is how you can actually appreciate the way how the seek and tell g is going to give you a lot of notations in terms of writing the file content, right? So maybe in case if I wanted to write a content over here, my file dot seek, right, and then if I try to write, I'm just doing it vaguely. So my file, so I'm writing this file, writing into this file. This is from the current position. Okay, so let me run this particular program again. Okay, so I'm going to run this program, and we got an error for the operation. Okay, so this is an input, right? We are trying to read this particular file. So this is not going to work here. If I create it as a FO stream, then I could have been able to write this particular file. Or in case if I'm trying to do it as the F stream and iOS in, and along with this, I'm going to have iOS out, right? In that case, I should be able to write into this particular file. I hope that should work for me. I didn't try it earlier. This is the write from the current position. Okay, so I'm going to write this particular file, and let's see what exactly happens. Found okay, I forgot to mention the full scope operator. Great. So here the byte size is now 54, what it is showing me. So let me go to that particular file and see what changes has been made. So you can see this is right. So if I count the number of locations, so 1 2 3 4 5 6 7 8 9 10, so then this is the right from the current position has been added to that particular place, and then it is being followed by the rest of the text which was written over there. So this is how you can actually plan for your file processing by utilizing these tell g, tell p, tell seek, seek g or seek p method, and then using the f stream method to write or read at the same time, or using the I stream for reading and O stream for writing to that particular file, right? So this is what you can do corresponding to your particular file handling stuff. So now we also spoke about the buffer, and buffer are some kind of temporary storage which is being used by the stream when the data is being read from the file and fed to the program, or vice versa. So when a buffer is worked out and we wanted to flush that particular buffer, basically it's clearing that particular buffer. All the data contained in it is written to the physical medium if it is a OF stream, right? Output stream. So this process is basically called the synchronization. So you remember we were using endl. So we were actually flushing it explicitly so that the synchronization would happen between the stream and the output console. So once the synchronization happens, it takes place under the following circumstances. When the file is closed, if I'm going to close the file, that means I'm going to call a close method. In that particular case, we are going to have, so before closing a file, all buffer that have not yet been flushed or synchronized and all pending data is written to the file to the or read to the physical medium. Now, when the buffer is full, the buffer has a certain size, right? So we know that resources are always limited; they are not unlimited. Even though we are in the age of cloud, still the resources are limited. So when the buffer is full, it is automatically synchronized, and it's the implicit work, right? And explicitly with manipulators, when the certain manipulators are used on the stream and explicit synchronization takes place, these manipulators are flush or end. So endl is used for the console and flush is used for the files as well. So explicitly with member function sync, the calling the stream member function sync causes an immediate synchronization. This function returns an integer value to -1 if the stream has no associated buffer, or in case of any failure. Otherwise, it will going to be returning the 0. So that means we can treat it as a success, right? So that is what we get in terms of our buffers, and it's the basic synchronization corresponding to its work. Now let's move toward the another topic that we have is the exception handling. And C++ is such a beautiful language, and it's such a beautiful addition of over the C constructs, that it allows us to handle the special condition of the code, which is generally in the logical context, uh, which may produce some sort of error and can lead to the termination of the program unexpectedly, right? So to handle such conditions, we can have the utilization of this particular exception handling procedure. So this is done by using the handler function, and generally it has been the code block or the section of code snippet which we think is going to give us an error is basically put into a try and catch block. So if we look at this particular example which is being provided over here, so what exactly we are trying to have is right now no exception class has been included, but it will be included further when we are going for a standard exceptions. But right now we are just throwing a basic exception by using a throw keyword, so it is not required. So we have a basic IO stream preprocessor. Then using the namespace standard we have, then we are starting with the main method, and your attention should be put on this. So this is a try block. So this is a throw new. So we are trying to throw an exception explicitly, right? And this is a catch. Now, if you look at this particular parameter, this int is actually related to this. So what value we are throwing as an error, that value will be given as a parameter also. Okay. So this catch is going to get, if any error is being thrown by this particular piece of code, it will be cached into this particular code block, and then further this particular concept can be utilized for printing that okay, there has been certain kind of error, and the number which is being thrown for the error is being cached into this, and that will be printed further. And then we can come to this particular return statement. Okay, so let's look at this particular code in the exception handling CPP. So here the code has been written, and I can simply show you the actual usage of this, because I'm going to type in this particular cout statement over here. This is after catching the exception. right? And instead of writing E, I'm going to have a simple over here, right? So if I run this particular program, you can simply, find it out. Okay, and great. So I made a mistake. Let me have this particular program in running mode. Okay, so we can see that an exception occurred, and the exception number 20. This is after catching the exception. Now, if I'm going to remove this particular try block, right, I'm throwing an exception, right? Then let's see what is going to happen in this particular case. So let me rerun this particular program for you. So if I run this particular program, you can simply see that terminate called throwing an instance of int, right? So that means the cout statement has not been called after the error has been occurred. So if I show you one more thing, let's say I'm instead of, because this might be confusing, I'm simply writing int a equals to 0 2 divided by 0, right? So let's see what exactly happens at this particular place. So if we try to divide the number by 0, the process returns certain value, right? Okay. This is a garbage value which we are using. If we try to divide 0 by some number, right? So in that case, this is after catching the exception that we are trying to have. So in the previous example, because we were trying to divide the number by 0, so divide by 0 error was supposed to be thrown, right? And then the cout was not being printed. This cout statement has not been printed in this particular output. So that means the process returned certain exception value. All right, it's a garbage value, ambiguous value, which has been done by this particular process. That means there has been an error to that particular calling operation, and the further instructions were not at all being executed. Now what I'm going to do is I'm going to, now this is a logical error, right? This is not a compilation error. So if I wanted to catch this particular logical error inside of my particular program, I can simply have that particular try block around this particular part, and you can simply see that this particular cout is going to get printed after this particular uh, catch of the particular exception. So you can view. Oh, great. So we have actually not got that particular throw exception. So if this happens, we are going to throw that particular exception. We know this is going to happen here. Let me see. Let me try this, because the same syntax works with the uh, Java programming as well. Okay, so the comma it is expecting. So we simply have this throw here. So here divide by 0 warning has been generated, right? The exception has not been caught in that particular process. So right now this is an explicit exception which is happening, and for this certain standard exception has been provided, and that is supposed to be cached over here. So we'll be looking at that particular standard exception first, and then we'll come back to this particular piece of code. So exception handling, we have said that there can be a multiple catch blocks which can be provided over here. So this is a catch set of catch block which we have. So here you can see there is only one try block, and there could be multiple catch blocks, and there is also a way we can do a nested try catch block. So that means within a try block there could be another try catch block, and then further it can be uh, you know uh, included with the catch block for the outside try. So this nesting is also allowed, and this multiple set of exception can also be allowed. So what we can try is we can try this particular catch exception over here uh, at this particular place. So here what we can do is we can have a catch right? And that catch should be provided with this particular set of combination. So we have three dots here. So that is what has been shown in that particular example. And let's see out and other exception catched. So let me run this particular thing. I'm not sure it is going to work in a way as I wanted to have it. Okay, so it is not going to work because we have to use only the standard, exceptions with this. So this is not the one, but if I remove this particular divide by zero error and if I use this throw right now, it will go to the integer part, right? So the exception is going to get occurred for the exception number 20, and this is after the catch exception. Whereas if I go for print, giving it another character, so let's say a, and if I run this particular part, because this is the uh, exception which is not from the caught exception, and that's why this particular other exception has been catched, and then this is the after catch the exception statement which is being printed. So if the throw which is being done corresponding to a particular set of catch is not available, then it will go to the default part. So it's almost similar to your switch case statement. So if we have the catch matching with the particular exception type, it will go to that particular exception. Otherwise it will go to the set of default exception that has been kept for that particular thing. Okay, so with this we have reached the standard exception. So we have a bad alloc exception that throws that is thrown by a new on allocation failure. So that means new keyword we are talking about. Then we have bad cast. The bad cast is thrown when the failure happens in terms of doing a typecasting. Bad exception thrown by a certain dynamic exception specifier. Then we have bad typed ID. This is been thrown by the type ID. Bad function call if an empty function object has been called, and bad weak pointer if the pointer which is being shared is being there in terms of uh, null section or the shared pointer, something like that. Okay, so this is what we have uh, in terms of our standard exceptions with respect to the particular exception handling of this particular C++ programming. So this is the end of our episode 9. If you have any queries, any questions, you can leave your comment in the chat section in next 5 minutes, and I will be answering your question corresponding to that. In the meantime, please subscribe to our YouTube channel, that is Superwits Academy, and do not forget to press the bell icon. That will give you a notification for all the new live streams or new videos or premieres that I'm going to do corresponding to other topics. Also, we are giving training on Python, C, databases, and machine learning. So you can connect to us at hello@superwits.com. Apart from that, we also run a Telegram channel for sharing the latest updates. You can simply search for Superwits Academy on Telegram, and you can subscribe to our Telegram channel as well. So I'm waiting for your queries for another 3-4 minutes. Uh, you can share that. I think there are no questions from your side. So we can simply stop our live stream now. So tomorrow is the last episode 10, which is going to talk about the online judge, and hope you will be able to join into that particular session where I will be talking about the various online judges and how you can utilize it, because a lot of pro- uh, programmers interview, like if you are applying for a job role of programmer, software engineer, and all that type of job roles, so you have to go and appear in that online judge during the interview process, right? So it's very important to make yourself familiarize with that particular type of environment, so that while actually facing the interview process, you should not be juggling with the basic utilization of the online judge. So in tomorrow's session we'll be talking about in detail that how you need to be pro with that. So thank you very much for joining in for this particular session, and see you tomorrow at 11 a.m.